Hello everyone, this is the summary for section 6.6 Calculus in Probability. So we talk about common PDFs and cumulative distribution function in this section. So there are three common PDFs for continuous random variables. The first one is the uniform distribution, the second type is the exponential distribution, and the last one is the normal distribution. For the uniform distributions, x, the continuous random variable, is equally likely to occur over an interval, and the PDF has the form that f of x equal to 1 over b minus a for x is between a and b, and 0 otherwise. The graph for the PDF has this shape. So as you can see right here on the left hand side of a and on the right hand side of b, the function is at 0, right? And between a and b, the function is the horizontal line. So therefore, f of x is equal to h equal to 1 over b minus a. And the second distribution is the exponential distribution. The PDF is the exponential decay function. It has the form f of x equal to k times e to the negative kx when x is greater than or equal to 0, and f of x equal to 0 otherwise, for k is the constant in this case. And the graph of the PDF has this shape, right? So on the left hand side of 0, or x is less than 0, the function is right on top of the x-axis. But when x is greater than or equal to 0, the function is the exponential decay function, right? And the y-intercept right here has the k value, which is the constant in our function. One interesting thing about the exponential distribution is the mean. Mu is always equal to 1 over k. You can identify the mean graphically by drawing the tangent line at this point k, and this tangent line intersects the x-axis at the point, and this point is the mean value. The last distribution is the normal distribution. As I mentioned in class, you don't need to memorize the PDF formula because it's quite complicated. This formula will be given to you during the test, but you have to be able to identify it. And the graph of the PDF has this shape. This is the bell curve, right? For mu, in this case, the mean, which is at the peak of the bell curve. And sigma is the standard deviations represent the spread, and you can identify the standard deviations by identifying the point of inflection, and the standard deviation is the distance from the point of inflection to the mean. You can do this on both sides of the curve. On the left hand side of the mean is mu minus sigma, and on the right hand side of the mean is mu plus sigma. We also learned about cumulative distribution function, or CDF, to show how the probability are cumulative as the value of the continuous random variable increases. And for more details of this CDF, I'm gonna make another video with some example and hopefully make it better for you to understand this material. And this is the end of the summary of section 6.6. Please let me know if you have any questions.